Hello everyone, welcome back to my channel. So in this video we are going to learn about naive Bayes. Okay. So what is naive Bayes? Naive Bayes is a classification algorithm based on the Bayes theorem, which was given by 18th century mathematicians whose name was Thomas Bayes. Okay. So naive Bayes is a probabilistic algorithm that relies on the principle of conditional probability. Okay. So what do we mean by conditional probability? Let's go ahead and see. So basically, what conditional probability means? Suppose we play cricket 20 days in a month. Okay, so I can say 20 days in a month. Okay, so what will be the probability of playing cricket in a month? So PA will be 20 divided by total number of outcome, in this case that is 30. Okay, so that is something basically comes around 2 by 3, or we can say 66% something is the probability is the coming. Okay, now suppose it rains 5 days or 10 days in a month. So on that days we will be like unable to play cricket. So that is a case of like probability of another event is affecting the probability of the main event, or we can say probability of A is affected by probability of B. Such scenario we see as conditional probability. Let's consider another example. Suppose you want to separate our email by spam and ham, and we know out of 100 emails, 20% is spam and 80% is ham. Okay, now suppose a email contain the word as Viagra. So it will increase the probability of the email having a spam. Okay, suppose it increase the probability of having a spam of an email by 70%. So this is something example of conditional probability, where probability of B is affecting the probability of A. So let me go ahead and give example, so we will understand it by example. First of all, let me write the formula of conditional probability. So what is the formula? Formula is P A by B equal to P B by A into PA divided by PB. I am sorry for my handwriting. Okay, so this is the formula. Now here PAB is the probability of event A occurring if B has already occurred. So okay, we will understand with an example. Suppose there is a disease that affect 1% of population, and you visit a doctor for a checkup, and doctor performs test to examine whether you have the disease or not. So this test is also not perfect. It produces like 5% of cases. So we can say 5% of cases as false positive, meaning it indicates the presence of disease when you don't have the disease, and 10% of the cases are false negative, means it failed to detect disease when you actually have it. So 5% are false positive and 10% are false negative. Okay, now let's calculate the probability that you have the disease or not if the result came positive. Okay, so in this scenario PA will be 0.1, that is a 0.1%. Okay, and P of BA will be 90.9. Okay, why? Because 90% accuracy in detecting the disease. 0.9. Okay, now P B when A is not or not A will be 0.05%. So if we try to calculate, if we put it into the formula, let me write it into the formula. What we get is 0.09, sorry, 0.9 0.9 into 0.01, okay, divide by 0.09 into 0.01 plus 0.05 plus 0.99. So that gives us like 0.15, means the probability is 15% that you actually have the disease. Okay, so that is something that is a basic intro about navy bias. In next video we will see in more detail what navy bias is and how to use it in our algorithms.